5-term, 2-variable polynomial, and it looks pretty promising at the outset. If you compare this initial condition with this factorization of the last two terms, you can factor 3 out of these last two terms and you end up with 2x minus y, which is the initial condition. Okay, we get a numerical value of root 21 over 5 for 2x minus y. And so at this point it looks fairly promising if you maybe do a factoring by grouping, but I couldn't get a common binomial factor right here. In other words, 2x minus y cries out as a common binomial factor, but I couldn't get that to happen over here. So what I did is I tried the next best thing, I guess, which is long division. Okay, and long division gives us a way to divide polynomials of any number of variables. And so I performed the long division. I won't go through all the details right here, but we did get a remainder of 0, and it's not the end of the world if we don't get a remainder of 0. Okay, but we did get a remainder of 0. We could still do the problem no matter what the remainder, but the remainder of 0 does verify that 2x minus y and 10x minus 5y plus 3 are factors of the expression that we're trying to evaluate. And remember, 2x minus y is equal to root 21 over 5, okay? Now, so that means we can rewrite it like this. This is the object we're trying to evaluate, all right? This is the divisor and this is the quotient. Now, just you see this remainder of 0 we got in the long division. I'll put the plus 0 there. It's superfluous and it's unnecessary, but just to show you the structure of the long division in the rewrite of the original expression, okay? Now, again, keep in mind, this right here, 2x minus y, is given to us as root 21 over 5. So let's see what happens with that. Okay, so we'll put root 21 over 5 right underneath. Root 21 divided by 5. And then notice right next to it in the parentheses, we have 5 times 2x minus y. You can factor a 5 out of this and get 5 times 2x minus y, right? And so right here, let me just continue to write. You would have 5. I could cancel it right now, but I just want to make sure. So we'll do root 21 over 5. Root 21 divided by 5. And then you still have the plus 3 hanging around over there. Okay. So y'all, again, we caught a break in the sense that this is just a scalar multiple of this. And this piece right here, 2x minus y, is the given condition. And this object right here is 5 times that given condition. Okay, so what does that lead to? We can see what's going on right here. Let's see, we have root 21 over 5. Does things cancel nicely here? And so what do we end up with? These 2 5s cancel, right? Okay, and so what do we end up with, folks? We get root 21 times root 21, which is 21 over 5. Let me write it right down here. 21 over 5. Okay. Again, y'all, right here, these root 5s cancel, right? I mean, excuse me, these 5s cancel. You still have root 21 over 5 out here. Okay, so you're left with the square root of 21 times the square root of 21 is 21 right here. Okay, and then we still have to distribute this to this term right here. So that would be 3 root 21. I don't know if I should factor this any further or not, but I don't know if it's any neat. We could just write this as 1/5 times all that stuff added together. But I'm going to leave it like this, folks. It doesn't really simplify anything in my humble opinion. So, y'all, this is the answer. Strange problem, but it was a lot more tractable than one might think upon. I mean, when you look at this from the beginning, it looks rather hopeless. Maybe you could say y is equal to 2x minus this and replace y's, but see, then you're going to have to square that. You would get a polynomial. That I don't know what's going to happen with that really. So I think the long division is the best approach, and I believe that's the correct answer. Hope you enjoyed.